Hey guys, we're going to do some energy and practice problems. So why don't you go ahead and get some paper and a calculator and a pencil, and I'll wait here for you. Okay, welcome back. So the first thing we're going to do is read our problem. What would the wavelength of light with a frequency of 2.56 times 10 to the 4th hertz be? Okay, so what I want you to do now is decide which of these formulas am I going to use. All right, so we're looking for wavelength. What is the symbol for wavelength? Okay, hopefully you picked this. This is the symbol for wavelength. It stands for lambda. Okay, so there is no lambda in this formula. There's no wavelength, so we're not using this. Boop, not that one. We have to use this guy right here. Okay, and so C stands for, hopefully you got that right. So we want to solve for wavelengths, which means we need to get wavelength on a side by itself. You could do that using the triangle method that I showed you in class. Okay, but here we go. We're going to say solving for wavelength, and that's going to make me have to do C divided by B. Okay, so go ahead and do that math. See if you can figure out what wavelength it would be. Okay, so I've got 3.00 times 10 raised to the 8th meters per second, right? That's the speed of light. Okay, and my frequency is 2.56 times 10 to the 4th hertz. Okay, so what am I doing? I'm dividing, okay? So if I just divide these, that should be my answer. And you should get what? Oops. Pick the one in the answer column that you got. Okay? All right. So you should have gotten 1.17, because we're doing sig figs here and we only get 3, times 10 raised to the 4th. And what's my unit here? Meters. Right? Meters. All right. So that's how you do that problem. Now, let's go down and do another one. So let's say, okay, we know the wavelength and the frequency of a certain type of energy. What would the energy of that wavelength be? Okay, so you're going to say, can I use this formula again? Nope, you have to use the other formula. So what formula is that? The other formula we're using is E, energy, equals H, which stands for, that's right, Planck's constant, times V, which stands for, that's right, frequency. So I'm gonna go back and just get my frequency from up here. Okay, I already know it. So I'm just going to multiply Planck's constant, which is, and hopefully you'll get this number memorized. I still struggle with it sometimes. I'll probably just give it to you on the test. You remind me that I said that. I might forget. Okay, so remember, for Planck's constant, I'm joules per second. Okay. That's a good fun one. And so all we're going to do is then multiply that times our frequency. To the 4th, right? Okay. So hopefully you go ahead and work that out. Okay, and so then when we're done, we're going to get a tiny number, right? So tiny. Because we're starting with Planck's constant is super tiny. So you should get this if I am doing my math right, which one can only hope. Okay, so hopefully you got that. And what's my unit here? Joules. Okay, so that's how much energy is in this wavelength. All right, so now what if we start all the way back at nanometers and work our way all the way through? So the first thing I'm going to ask you is, how many nanometers are in 1 meter? Hopefully you got that there are 1 billion. And so here's how I'm going to write that. I'm going to say that I need to divide by 10 to the 9th, because that is how many nanometers are in 1 meter. Okay, so I'm going to go ahead and divide by that, and which gives me, now my new unit is meters. Okay, yay. So now I'm in meters. Now I can go and use my formula. So now you type for me the next formula you're going to use. And hopefully you went up here and got this. All right, so we're going to use this guy. We're going to put our, I'm going to rearrange it. So we're using this. Okay, so now I want you to try and go and find the energy of that. Okay, so you got to find wavelength first in this situation. So you should have done 3.00, right? This is the speed of light. And you divided it by our wavelength, 7.22 times 10. Meters, okay, which gave us like 4.15512 times 10, 14-ish hertz. Okay, so now I'm in frequency. Now I can go get this formula and bring it down. Okay, so now I'm just going to take Planck's constant times this little friend, okay, and that should tell you how much energy is in that wavelength, or that photon. Okay, so you should have hopefully gotten something like this. Really tiny number. And the unit for that is joules. So anywhere along the way, I can ask you any one of these variables and you need to know how to put it all together. If you have questions, let me know. You're going to do great. Love you.